All right, here we go with the gas laws. In the last set of videos, we talked about some relationships, and so now we're going to give names to those relationships. The first relationship or gas law that we're going to talk about is Boyle's law. And Boyle's law discusses the relationship between pressure and volume. So if you'll see over here, we have a bag of chips that's laying on the dash of my car, and this is when we were at low altitude. This is where the pressure is high. So this is high pressure. And then up here, this is when we were at the top of a high mountain plateau. And so this was at a lower air pressure. That's because this was on top of a mountain and this was at like sea level, you know, so down here, this is where the sea would be. Anyway, notice that the volume of the bag, how much space the bag is taking up, is not very much when the pressure is high, but as the pressure goes down, the volume increases. So we said that pressure and volume were inversely related. As one goes up, the other comes down, and vice versa. And so then we said one way to show this proportionality is to show that the pressure is proportional to 1 over the volume. Now instead of putting a 1 here, I put a k, and this is a constant value. So, you know, like in math class, you use K or C or anything for a constant. And then what I want to do is I want to show you what do I have to do to the pressure and the volume to keep it constant. And so if I move the volume to the other side by multiplying both sides by the volume, so like saying multiply this side by the volume and this side by the volume, these cancel. So I get that the pressure times the volume equals a constant. So if I always multiply the pressure value times the volume value for a given situation, I'll get a constant number. The second gas law we want to talk about is Gay-Lussac's law. And Gay-Lussac discusses the relationship between pressure and temperature. And I don't know if you know this, but if you've ever checked the pressure in your tires in your car and done it correctly, you'll notice that you should always check the air pressure when it's cold. And the reason we want you to check it when it's cold is because the temperature of your tire affects the air pressure inside. Temperature and pressure are related. So after you've been driving on the road for a while and your tires heat up, the pressure actually goes up. And so we learned that pressure and temperature are directly related. So if the temperature goes up, the pressure goes up, and if the temperature goes down, the pressure goes down. And so we wrote a proportionality where P was proportional, or the pressure was proportional to the temperature. And once again, here's that constant. And so what would this equation look like if I solved it for the constant? And if I did that, I would learn that the pressure divided by the temperature is always a constant. The next gas law is called Avogadro's law. And Avogadro, because Avogadro had to do with the mole, it's the one that shows you the relationship between the volume and the concentration of a substance, of a gas. And so you'll notice here, this young man is blowing up a balloon, and as he adds more, that means as the concentration is going up, as he adds more air, look what happens to the volume. The volume also goes up. So since they both go up together, we say that volume and concentration are directly related. And so once again, we have this direct proportion. Notice that the volume is directly proportional to the concentration, and there's that constant again. So if I solve this for the constant, I learn that the volume divided by the concentration is equal to a constant. The last of the gas laws that we're going to look at is Charles's law, and this is the one relationship we didn't discuss in our last set of videos. Charles's law discusses the relationship between volume and temperature. Oh, I notice I have a typo here in my slide. So this should not be N, this should be T for temperature. And to demonstrate this relationship, I have a quick video that I want us to watch. So let me grab my arrow so we can click on this. This guy's a little bit hard to understand, so I'm going to narrate over the top of it. What he has here is a helium balloon. See, it's going up on its own. And in this thermos here, he has some liquid nitrogen. And he's going to pour the liquid nitrogen over the balloon. And as he pours it over the balloon, look what happens to the volume of the balloon. Can you see it shrinking? gets smaller and smaller. Oh, look at that. So the volume is going down. So as the temperature goes down, the volume goes down. Now he throws it on the floor, and as it sits on the floor, it starts to warm up. And as it warms up, the volume increases again. All right? So what we've learned is that volume and temperature are inversely related, or directly related. As the temperature goes down, so does the volume, and as the temperature goes up, so does the volume. So we have that direct proportional equation that comes up, and if we solve it for the constant, we get that the volume divided by the temperature is a constant value. Well, if we take all of these four laws together, there are two actual gas law equations that we can use in chemistry. The first of these is called the combined gas law. And the combined gas law does not deal with concentration. It only deals with pressure, volume, and temperature. So if you were to go back through the slides and look at how all of those equations are equal to a constant, we learned that the pressure times the volume was equal to a constant. We learned that the pressure divided by the temperature was equal to a constant, and that the volume divided by the temperature was equal to a constant. And so I can combine those all together, and I can say that if I multiply the pressure and the volume and I divide it by the temperature, I will always get a constant. Well, that means if I take the pressure and the volume and divide it by the temperature in a before scenario, it will always be equal to the pressure times the volume divided by the temperature in an after scenario. So the combined gas law that you need to know, this, and by the way, this is on your blue periodic table, but you need to know this combined gas law. The second gas law is called the ideal gas law, and this one does not look at a before and after scenario. It just looks at the relationship between pressure, volume, concentration, and temperature. And then here, instead of using K for a constant, we're using the letter R. And the reason we're using the letter R is because this constant now has a known value. R is a constant, and as long as we are at standard temperature and pressure, so as long as we are at 0 degrees Celsius, or 273 Kelvin, and 1 atmosphere of pressure, then we know the value of R, and this is a number that you need to memorize. So let me put this down here really quick. You need to memorize this R value. And so it is 0.0821, and then it has this weird units. It's a liter times an atmosphere divided by a mole times a Kelvin. And that is the unit for the ideal gas law constant. That's it for now.